So we're here to solve this Araf puzzle by Jeffrey Bardon called '09. You can see in the initial theme all these 9 clues and 99 and 999 clues that make up a lot of the theme. I'm going to customize my solving interface to just add in surface in my tab options so I can go to it quickly and do some coloring. By default, line and edge are both on in this space. And one reason I want to get to surface is to show a few things that should stand out right at the start of the puzzle. The first is you can make a mental calculation. There are 20 clues in total, 10 of which are small nines, 10 of which are large 99s or 999s. And in an Araf, the small digits are more often important than the large digits. If you replace these large numbers with infinity symbols, they would mean about the same thing in the puzzle. But the small digits are always a lower bound -1 of the size of the regions. And if the lowest digit in any of these regions is a 9, that means the smallest of any regions we can draw need 10 cells, and there are 10 of these cells that I've marked in green. So we need 10 regions that are no smaller than 10 cells large, and 10 by 10 is 100. This is a 10 by 10 grid. It's a way to recognize we have to make exactly 10 cell regions in the grid at the start. And so what we really now are thinking about as we go through this whole solution is where are there clues, small and big, that are connectable within 10 cells, and can we form 10 such connections and efficiently pack the grid to completely fill the space. So this clue in the upper left, this 9, has to escape out in these other green cells. And because we have part of the region on the border here and the clue itself on the border here, this is a kind of deduction you'll see in other puzzles like Nurikabe or other places. We've got to keep hugging along the border for sure. These 10 cells in green must be part of this region. And when we have those 7 cells, these 7 cells in green have to be part of the region. When we have these 7 cells marked, we can't come down and take 4 more cells. This is 11. This is 12. The only option that is just 10 cells away ends at this 999. And for sure, we actually know that this is a bottom edge and right edge, and these are actually all edges. There are 3 options for this shape. It's this one, and this one that connect together and use 10 cells exactly. But we've got that as a starting point that starts to limit the grid in a few interesting ways. Another thing that's going to limit the grid is this big clue in the end of row 6, which has to dodge the other large clues near it. And in coming out is going to start to take at least these cells in red and give us a space where we can now think about one of the global constraints, which will be key in this puzzle, which is that we have these clues in the bottom that are all fairly big, and you've got a fair number of small clues on the top. And so there aren't going to be so many ways to connect up these big numbers with the small numbers. And one thing I see at the start, recognizing I can no longer come through this channel, like we talked about how the green region is going to block paths like this. This lower left clue has what look to be maybe 3 circles that are nearby, but this circle right here is 11 cells away, so too far away. So there are only these 2 circles we could connect with. And a thing to note, regardless of how you connect, this cell up, if you came to this one in the 8th row, the 99 on the far right in yellow has no way to get out and back into the grid. You will effectively, in making these connections, strand 1 or 2 large clues together, but there are no 9s that can come back into this space because of the cells marked above in red coming out of this clue and all the blockers that are in B between this 9 and 999. You can't wrap around this big region. So at the start of this, we have effectively identified that in pink, these 2 regions will come together. They can come together in the way I just showed, which is to the bottom and right of this orange clue 999. They can come over here to the left. And there are places where there's more flexibility, like these can go this way. You can take 1 more cell. There are a lot of options here, but the topology of the connections is what's key. And one of the things I'm seeing that's making me think about these options is that in one of these scenarios, orange is going to come up through this group naturally to the left of this clue, and that's going to leave effectively 3 or 4 columns of space to the right that things can come through. And in the other option, orange is going to come in like this, and itself probably be pretty limited in the remaining space. We'll end up needing to get effectively blue up and around. Like blue can't come to here, we isolate the 99. in yellow again, and so blue has to come up like so. And actually looking a few steps ahead here, we've got 7 cells in orange. The only number that the orange can actually connect with is this one, which now actually means this blue is going to have to keep coming to the right, and we get a collision here of these groups. And so there's a general packing constraint that I think is true in the 6th row, that you almost have to have all of the vertical options be available for different groups. And it very much looked, when we were exploring them, that the orange has to be the left of these. We're going to end up with the pink being to the right side of that and connecting somehow like this. A lot of flexibility to it. But with those as starting points, another tension in the puzzle are going to be cells like these in dark gray. And the reason they're a tension in the puzzle is they're not going to be able to be reached by any part in green. We showed that these were the furthest to the bottom of the grid the green cells can be. And once we know the pink comes over like this, the pink is taking 9 cells, so we could take a 10th in places like this, but we can't reach into these dark gray cells at all. And so let's think about how those cells can be able to be in orange and then still be filled in as we fill in the rest of the puzzle. So this cell for sure can't be pink. If pink is coming, let's sort of draw the tightest pink path we can, which is something like this. We can take one more cell in pink, but there's no way we can get this corner cell in orange. And orange will have to be between this channel, and there's no pink between green and this channel, so this cell also has to be orange. And then by other limitations, this has to be orange. So we've marked 7 cells in, and these 7 cells actually give us a pretty limited space where there are 2 numbers we can connect with. And actually, if we connected to this top 9, we would now have isolated this bottom 9. So we know for sure actually this connection is where the 9 goes. And we actually can't take any more of these cells here. So we're in a space where we've actually, by just placing some things intuitively, recognized we have to grab one of those 3 cells we initially marked in dark gray that I'm now sort of dragging the mouse over as potentially in pink, but these other 2 in orange. This is a way we can take all the cells we need to take, and at the same time as taking them form a valid group. This is 10 cells large in pink. We can't take these cells, so they're going to come back and have to be green. And marking in these edges, we're going to see that we have to take these bottom cells in orange. And we've got this start to the puzzle, and now have to consider some of the harder steps that are going to still pop up, which is now these cells that are in white, but with a line connected to them, have to connect to some 9 somewhere, and they have to be able to extend in the grid. And it may help to recognize that, again, the blue doesn't connect over to this 9, but these cells pretty much want to be connecting to the large number in blue. There's no other large number that's within 10 cells of this first cell. The 99 is 11 away, and these other numbers are all far apart. So these cells being in blue gives us a kind of constraint, which is however they come in, these 6 are part of them, and recognizing this can't be part of blue because it's going to isolate too much of the corner. When I only have 4 more cells to go, this must be in blue, and coming back, we can now actually deduce things like this must be in yellow, and red has to come up like this, and we can start to form some more colors, but let's do light green, and let's do, I guess, another green over here just because we're running out of shades. This is some of the look of the right side of the puzzle as we're getting to it, and the connections over here are fairly limiting. We actually get another space of colored cells here that can't be in blue, have to connect to some group, and they're actually in a space they can't get all the way over to this set in red, so they're going to have to be yellow. And with these in yellow, we now have a space where we've got to keep doing efficient packing. These in yellow are on a border. This 99 is on a border, so I've got to take everything along a border. That actually gives us 8 cells there, plus the 9th, which will be this 99. So one of these 2 is coming in. We don't know for sure which, but we can mark many of these edges. And this cell here is going to be in a different color. And recognizing the only group that's near it is the orange group that's above it, you can ask, does it come this way? That's taking too many cells. It's taking 11 there and not yet through a 9. Or it can take this one. And if it takes this one, then the yellow option that's left is here. And coming back to the edges we can draw in, we know these now mark off the rest of blue, yellow. We've got to get still this red group to a 9. And the only one that's close is this one here. So these, sorry about that, picked the wrong colors briefly. These will keep extending. With 9 cells in red, we have to still take cells like this cell, but it can't be in red and it can't be reached by other groups. So the blue is going to have to come in like so, and we're going to get another case where we finished off a group. We have a new color, we don't know where it is, but it's going to take these 4 cells and connect to something else. We can do some with this upper right corner, and it's not that we know for sure what 9 the 99 takes in green, but if it takes this or if it doesn't take this, it's still going to take these cells. And similarly, the one in gray, it can take it can take this or not, but whatever it takes, it's going to take these coming further to the left. And let's take another color here, and we can take, let's use brown. This is another big number, and it's going to be coming over to the left. And now we can start to think about what is going to be able to take these cells down here, and could it be this group in brown? And the answer is no. Could it be this group in gray? The answer is no. Could it be this group in light green? The answer is no. It's got to be this group. So we're gonna, let's come back with yellow, since we have yellow isolated in the corner. These digits come together, and with these coming together, we now actually have started to form a barrier to this left of the grid, that a cell like this one right here, this 9, can't connect to any other colored group except for the one in yellow. And that's a very interesting constraint, but it lets you efficiently pack these cells together as a group, and we can color those in. It will now start to form a new group that's going to come out here with this 9, and this 9 has to extend out and keep getting to a larger digit. And when you try to do that, you'll see that it ends up that it's going to be a group in brown and has to take these cells. Now if we come back up to this digit, this has to extend out, and we'll connect up with this green group, and that actually is fully formed with 10 cells. So we're going to take this one as well here. The group in gray now must take this 9, and it's taking 7 cells, so 8, 9, 10 takes these, and this brown group still is able, let's see, where do I have, sorry, red is still able to take 1 cell. And so there are these options, but if red took the top one, it would limit what gray can take. And so these are the groups, and now to just check our solution, we'll draw all the boundaries. But hopefully you got a sense, this puzzle being a pretty unique example of an Araf, it really broke to a variation, which was fill in 10 10-cell regions and do those in a limited way. The connections of large with small were key, and particularly across this 6th row, where you see there are effectively 1, 2, 3, 4, 5, 6 changes in color across all these spaces. That space of large getting from the bottom of the grid to the top was a key constraint, and one of the reasons the pink couldn't come to the left and above this group. It would force too many connections to the right side of the grid. And so getting this 99 in orange to the left and pink to the next spot was the key seed in this corner. And if you didn't eliminate the other option, you could have been struggling for a while to make progress. So hope you learned a little bit about this puzzle, enjoyed the solve, and we'll see you again soon.